Hi, I'm Professor Baldwin, and today I'm going to teach you the properties of logarithms. Our first property is the product property. And for all of these properties, we're going to let b, x, and y, any variables we're using, are going to be positive real numbers, and our base b cannot equal 1. So for the product property, if you have log with base b and an argument x times y, you can separate that multiplied argument into two separate logs. You keep that same base, so it's log b, and you separate those arguments. Let's use that in these next two examples. Example 1, we have log of base 4, and the argument is 16 times a. We can break that up into two logs. Log of base 4 with argument 16 plus log base 4 argument a. We're not finished though, because we can simplify this very first log. Remember what it means. The base to what power equals the argument? Well, 4 to the power of 2 gives us 16. So the logarithm simplifies to 2. And we can keep that second log base 4 of a. Let's look at example 2. Here, our argument is x plus y times z. Be careful. The product property tells you can separate arguments that are multiplied together. So the two arguments we're separating are x plus y and z. That'll give us the first log of log base 2 with the argument x plus y plus log base 2 of the argument z. We cannot separate that log base 2 of x plus y. We don't have a property for that. Our next log property is the quotient property. Again, b, x, and y are positive real numbers, and b doesn't equal 1. The quotient property, remember quotient is when you're dividing, says that if your argument is two arguments being divided, you can separate that by subtracting the log of each argument. Let's look at our examples. In example 3, we're taking the log of m plus n divided by 100. Our first log would be log of the argument m plus n minus the log of the argument in the denominator, 100. Remember, we cannot separate that m plus n. There's no log rule for that. But if you look at this last log, log of 100, remember, when we don't have a base, it's an implied base of 10. We can simplify this because this is saying 10 to what power equals 100. Well, the power you raise 10 to in order to get 100 is 2. So this simplifies to log of m plus n minus 2. In example 4, we're taking the natural log of e divided by 12. That gets separated into the natural log of e minus the natural log of 12. Well, we can simplify the natural log of e because remember, the natural log is the same as a log with base e. And when your base and your argument are the same, so here our base is e and our argument is e, the result is 1. So this simplifies to 1 minus the natural log of 12. Our next property is the power property. Again, b and x are positive real numbers, and b is not 1. And p, which is our exponent, can be any real number. If you have an argument raised to a power, so here our argument is x to the power of p, The power property says you can take that exponent, p, and multiply it by the log of just the base of that exponent. Let's look at our examples. In example 5, notice that our argument is a fifth root of x to the power of 4. So on the side, let's simplify or rewrite what the fifth root of something means. Well, the fifth root is the same as taking an exponent of 1/5. And if we use our exponent rules, a power to a power, you would multiply, so this is the same as x to the power 4/5. So the log we're given is log base 5 of x to the power of 4/5. Now we can use our power property of logs, which tells us we can take the exponent of our argument, 4/5, and multiply it by the log of the base of that argument. In example 6, we're taking the natural log of x to the power of 5. Our power property tells us to take the exponent and multiply it by the natural log of that base x. Now let's combine all of these properties together to rewrite this natural log as an expression that uses the sum or difference of logs. Well, first, notice that we have the fourth root of our argument. Let's rewrite that as an exponent. That would be a squared plus 4 over e cubed to the power of 1/4. First, we'll use the power property that tells us to put that exponent of our argument in front and take the natural log of what we have left, a squared plus 4 over e cubed. Now we can use the quotient property to break up that fraction. We have 1/4 times the natural log of the numerator minus 1/4, because remember this 1/4 is times that whole natural log, so 1/4 times the natural log of the denominator. But we're not done. Look at this very last term. The natural log and our expression has an exponent of 3, but it's also an e, and the natural log is a base e. And if the base of your log is the same as the base of your expression, you just keep that exponent of 3. So our first term stays the same, 1/4 natural log of a squared plus 4. But our second term is 1/4 times 3. Or the whole thing is 1/4 natural log of a squared plus 4 minus 3/4. In example 8, we're going the opposite direction. We're given 3 different logs, so each term is a different log, and we want to express this as a single logarithm, and then we want to simplify it if possible. First, notice that the base of all of our logs is the same. That's important. They have to have the same base. These first 2 terms are being added, which means we can use the product property, which tells us log base 3 of 54 times 10. This last term is being subtracted, so we would divide by that argument, 20. Now let's simplify our argument. Log base 3, 54 times 10 is 540, and our denominator is 20. We can continue to simplify. This is log base 3 of 27. That's as simplified as that expression can be. It's already down to 1 logarithm. But we can actually evaluate this because log base 3 of 27 is saying 3 to what power equals 27? Well, 3 cubed. So the answer here is 3. So we simplified it and we gave the answer. How about example 9? There's a lot going on here. So let's go term by term. This very first term, we have 1/3 times the natural log. Well, that 1/3 is the power property. So we can rewrite that first term as the natural log of t to the power of 1/3. And we can keep the other 2 terms for now. And notice that all 3 terms are natural logs, so we can easily combine them into one natural log. Okay, next step. Notice that the first 2 terms are being added together, so that's our product property. And the third term is being subtracted, that's our quotient property. So we combine these, the natural log of the 2 things being multiplied together, t to the 1/3 times t squared minus 9, divided by that last argument, t minus 3. Now let's simplify. In the numerator, t to the power of 1/3 is the same as taking the cube root of t. And notice our denominator has t minus 3 and our numerator is t squared minus 9. That is a difference of squares. So we can rewrite that as t minus 3 times t plus 3. That allows us to simplify the t minus 3 in the numerator and the denominator. Because they're all factors, they simplify down to 1. So our simplified single logarithm is the natural log of the cube root of t times t plus 3. Thank you so much for watching. I hope you found this video helpful and you'll check out some of my other math videos.